These students are taking part in a series of practical activities designed to support their understanding of quadratics. In the previous lesson, they had used different sized tiles to deepen their understanding in factorising quadratics. Now the teacher wants to use these same shapes to build on the students' understanding of completing the square, beyond simply applying a formula to an expression.
I want you to get out these rectangles, please. So, our big square, 4 rectangles, and 6 little squares, like what I've got on the big screen. What's the area that I've got there? Go on, Laura. Nice one. X squared plus 4x plus 6. I want you to try and make a square out of that.
We'd have to have like 4. We've got 6. And that's a square.
So in general then, what I've got is I've started off with an area of x squared plus 4x plus 6, and I've made a square with sides x plus 2, and I've got 2 little squares left over. Have a go with this one, okay? We've got one big square, this is 6 rectangles and 6 little squares.
It's just 3 squares off every time.
You can't complete that because if you put that there, then that's not a square because that's not equal.
You need 3 squares extra every time to do it.
So you need 3 more little
enough.
squares of 1 to make the square.
It'd have to be x squared plus 6x plus 9.
Before, I found it difficult at the start, and me and my pair who we were working with found it hard because we were trying to make them symmetrical all the time. I think some people, and Sue was explaining on the boards, you had to make sure when you're doing the square that if you put the same number on the side, you had to put the same number on the top or the bottom, so the dimensions would be the same.
I've got 6 rectangles. I need to put them so that I have an equal number, because if I don't do that, then it's not a square. I put 3 to the side and 3 underneath. Where did the little squares go? Like what happened there? What was the problem there?
There was 3 less.
Yeah, I had 3 too few for what I needed to make a proper square.
This shows on this shape that we've made that in order to complete this into an exact square, we'd need 3 extra pieces that are worth 1. So we'd need 3 extra of these small squares to complete it into one complete square.
You can also see that the x plus 3 in the brackets is equal to x plus 1, 2, 3 on the sides, x plus 1, 2, 3 on the sides, which is where you get the x plus 3 squared.
So I'm going to put some questions on the big screen, draw the shape that you've made, and then tell me what the area of that shape is.
But then you need 1. Yeah, so would it be x plus 2? And then, what was minus 3?
So it's x plus 3 squared and then plus 2.
Yeah, so if he's getting... Am I leaving? Tom, are you taking this off me?
I'll leave it on for the time being.
When you're making a square, x squared plus 4x plus 1, what have we got there? X plus 2 squared, and then minus 3. What about this guy here? X squared plus 6x plus 7.
Some questions in a GCSE paper, you need to have connections between different areas of study and different ways of looking at it, and having that background knowledge does provide a little more insight into the question itself and how to best answer that and how to best tackle that.
When we come and use these squares, you can see in this example, you're 3 squares short, and so that is why you've got minus 3 on the end of the outside of the brackets. And it kind of it shows you a better light and gets you understanding the things much, much better.
Once the students are familiar with using these tiles, I think then the idea of trying to complete the square becomes much more concrete. In an example, you might be trying to fit tiles in to actually complete the physical square that's in front of you. And I think that adds an extra layer of meaning to what we're trying to do, which is a very useful and powerful technique. But sometimes the students don't necessarily appreciate where it comes from, and this maybe gives them an idea of where that comes from.